back to another IB Tutors video. Today we will be discussing the properties of water. We will, however, be discussing a few the molecular structure of water. So oxygen, hydrogen. As you can see, this creates a partial positive on hydrogen, partial positive on hydrogen, and a partial negative on oxygen. Since oxygen has more protons in its nucleus, it has a greater pull on the electron that they share covalently. These are covalent bonds. So it'll pull the electron that they're sharing between hydrogen even closer to the oxygen. That's what creates the partial negative, and that's what leaves hydrogen with a partial positive charge on both sides. This water molecule also has a dipole moment, that the net dipole moment of this molecule is somewhere like this. Therefore, this also means that the molecule is polar. What this also means that it's easy for it to create these hydrogen bonds between other water molecules. So for example, it'll create the partial positive of hydrogen will be attracted to the partial negative of oxygen. This will form something called a hydrogen bond, which is a very, very, very strong bond, but the covalent bonds between these ions are much stronger, of course. And we can go ahead and finish this water molecule off. Partial negative, partial positives. We'll take a look into methane as well because we will be using it later in this video. So methane is CH4 chemically. Therefore, it will be 4 hydrogens around the central carbon because carbon is less electronegative than hydrogen. Therefore, it's going to be like this. It'll be the central atom. Okay. You could argue that carbon would be partial negative, hydrogen would be partial positive, as the carbon has more protons. Therefore, it is attracting the electrons more towards it. And that is very true. So individually, between the atoms, there is a dipole moment. This dipole moment is like this. However, since the individual atoms each have that dipole moment going in like this, they all cancel out. The one going up here cancels out with the one going down here. So you can see, and the one to the left cancels with one to the right. Therefore, the net dipole moment is what we're looking for in these molecules, and the net dipole moment would be 0. Therefore, this would be a non-polar molecule. Okay, this is important later on. So now that we have taken a look into these, and we know that polar molecules such as water can form these hydrogen bonds, what does this mean? This means cohesion. This means adhesion because it's polar. Cohesion stands for the forces of attraction between two molecules of the same substance. If we have water right here, like a pond of water, and we have like a little insect, right? What gives the insect the ability to walk on water, essentially? The cohesion, or the cohesive forces of the water molecules, which create these hydrogen bonds the water so tight and packed together that it allows the insect to essentially walk on water. Now, the reason why we can't walk on water is because our masses are much greater than the insects, and therefore we will actually break those hydrogen bonds if we try to step on water, essentially. However, if we were light enough, then yes, theoretically speaking, we would be able to walk on water. So, adhesion. Adhesion stands for the force of attraction between two substances of different two molecules of different substances. Two molecules of different substances. For example, we can look at a leaf, and we can look at water droplets, how water hangs on leaves. Or if we have I cannot draw spider webs and drops of water, You can see how the water sticks to the surface of the spider web, or in this case, the leaf here, the water droplet is on the leaf. This is an example of adhesion. Capillary action is the ability of water to move against gravity. Against gravity. This is due to the two forces, adhesion and cohesion. This is a very important property of water because this is what essentially gives the water molecule these very, very good thermal properties that are used in organic. So for example, water would have a high specific heat capacity compared to methane, for example, which, since is not polar and cannot form these hydrogen bonds, methane would be, let us actually make a comparison between the two. So water, high specific heat, methane, no. Low specific heat capacity. Water has high latent heat of vaporization. Methane does not. It has a low vaporization, high vaporization temp. Water has a high boiling point, right? And methane does not. Low boiling point. And these properties are due to the many hydrogen bonds that need to be formed or broken to change the temperature of a state of water. So these hydrogen bonds, like we discussed earlier, are very, very strong. And that's why they're very important in this scenario. Because, for example, if we look when we sweat, the reason why sweating is so efficient is because water molecules are being evaporated from our skin, and tissues underneath the skin directly will be cooled down in the process because water alleviates, since it requires a high vaporization temperature and a high specific heat capacity it has, it's able to absorb all of this body heat that we have, and once it is evaporized in the air, it therefore cools us down. That's why it's so important. Water is great for sweating. In comparison to methane, if someone sweats and methane is being evaporated from their skin instead of water, then it is very, very inefficient and they will essentially die from body overheating, especially in intensive workouts. They'll most likely pass out. And if the body is unable to cool down in this specific period of time, then yes, that will lead to death. So when we're looking at sweating a little bit more further, it is important to know how this happens. So the hypothalamus of the brain essentially has receptors. These receptors monitor the blood temperature, and when the body overheats, it signals the sweat glands to secrete the sweat. The required heat for the evaporation is extracted from skin tissues, in turn cooling them, and therefore cooling the blood flow. This is most effective due to the high latent heat of vaporization property that water has. The hydrogen bond break causing this. Moving on, a little sidetrack here. Water dissolves many organic and inorganic substances that have charged or polar regions. It forms shells around polar or charged regions, and it keeps molecules from clumping together in a solution. So that's a very, very strong property of water. The reason why it's very important is because it's able to dissolve many important ions and molecules that can be used for transportation, especially in the blood plasma. So water's nature as a solvent means substances dissolved in it can react with one another. So the main component of cytoplasm, where many reactions occur, is actually water. So all substances that dissolve in water are hydrophilic, including polar molecules such as glucose and particles with positive or negative charges such as sodium and chloride ions. Substances that water adheres to are cellulose, for example, and they're also hydrophilic. Any substance that dissolves in water has to be hydrophilic, and any substance that water adheres to is also hydrophilic, such as cellulose. The important part that you need to take away from this video is that cohesion and adhesion is very important to know for your exam. That water has a high latency heat, that water has a high boiling point heat, that water has a high vaporization heat, and the reason why water is so great and so efficient at cooling down the body in the form of sweat. You should also know that molecules that are soluble in water are generally polar, just like water. Molecules that are non-polar are soluble in non-polar solvents, such as methane, benzene, such as acetone. So make sure you keep those in mind. Good luck on your next exam, and take care.